Good morning, students. I am Dr. Nagesh Bhandari from Department of Chemistry, Anantara Power College, Perumud. Today we are going to see the basics of organic chemistry. We know that organic chemistry is quite difficult for many students because they don't know how to deal the organic chemistry, what are the useful tricks for dealing the organic chemistry. Here we see that organic chemistry is defined as the chemistry of hydrocarbons. That is, mostly we can say the carbon whenever it is bonded with hydrogen, we can define it as a organic compounds. Apart from that, when the hydrogen is replaced by another element, then we can call it as a hydrocarbon derivatives. This hydrogen can be replaced by nitrogen, oxygen or other halogens. Now, in organic chemistry, we can say that there are two ways for writing a bond. Many people write directly the single bond between the two atoms by using the Kekulé formula, while there is another way by writing the molecule by using the condensed formula where we don't write directly single bond, we omit it. Then by knowing that, we can write in both way, that is, we can draw a line between the two atoms, or without atoms we can draw a structure. This is very important. Many students confuse with them. After that, we can say that in organic chemistry, we can write the number of structures depending upon that. If you see here, in case of ethane, there are simply, I shown here, the carbon is bonded with all hydrogens and a carbon atom. Similarly, if a double bond is present, a carbon and carbon double bond can be shown in between them, which indicates that carbon there is sp2 hybridization is involved. While in case of ethyne, we can say that the sp hybridization is involved, because of that which the carbon-carbon triple bond is shown. So likewise, we can draw any type of structure using the Kekulé formulae, or sometimes if the structure is long, we can go directly through condenser formula. So here the condenser formula I have shown example without writing the same structure of ethane, I have shown directly CH3. So no need of writing the carbon-carbon single bond here. Mostly this structure is used whenever the large structure is present in the organic compounds. Now in organic chemistry, we can say that the many basic things are there. So in organic chemistry, there are only 5 elements are there, that is carbon, hydrogen, nitrogen, oxygen and halogens. In halogen, we can say there is a fluorine is there, chlorine is there, bromine is there and iodine is there. Now you remember that if you know the basic properties, that is, if you know the atomic number, if you know their electronegativity, if you know their hydrogen bonding strength, or if you know their valency, their electronegativity, then it is quite easy to understand the organic chemistry. So here I have shown that the basic things which we should know about organic chemistry is that we should know in organic chemistry number of atoms are involved. I told you there are 5 atoms are there: carbon, nitrogen, oxygen, halogen and oxygen. Apart from that, we should know their valency, we should know their electronegativity, we should know their inductive effect, their resonance effect, and finally we should understand the term of Rhodes. Here when we deal with elements, you remember that there are 5 elements are there. I have shown here hydrogen, its atomic number is 1, its electronic configuration is 1s1 in the ground state, and even in excited state we can say that its electronic configuration is only 1. So because of that reason, you remember that its valence is 1. That is very important, because the number of unpaired electron in its outermost valence shell is only 1. Similarly, in case of carbon, its atomic number is 6. So its electronic configuration is 1s2, 2s2, 2p2 in the ground state. But in the excited state, one of the electron from 2s orbital is promoted to 2pz orbital. Because of that, we can say that the electron configuration becomes 2s1, 2px1, 2py1, 2pz1 in excited state. As there are 4 electrons are present in its outermost valence shell, we can say that its valency is 4. The valency term, you understand that whenever we are going to draw carbon on a paper or on a blackboard, we have to write 4 bonds. Similarly, for hydrogen, we have to write 1 bond. Just like a man, we are having 2 hands. If I tell you draw the structure of a human being, then you remember that you are going to draw 2 hands. Similarly, when I draw hydrogen on a paper, you remember that there is only 1 bond should be there. For carbon, there are 4 bonds should be there. Likewise, for nitrogen, its atomic number is 7. So because of that reason, the electron configuration is 1s2, 2s2, 2p3. And here in the excited state also, the same electronic configuration is going to maintain here. and as a result the number of valency of electron is 3. That is, nitrogen forms 3 bonds whenever it is present in organic compound. Then finally the oxygen is there, its atomic number is 8, so its electron configuration is 1s2, 2s2, 2p4. That is 2, you can say that one of the electron is promoted from this 2py, 2p4 to 2pz1. So because of that reason we can say that there are 2 unpaired electrons are present, and that's why the valency of this oxygen is 2. That is, oxygen, whenever we are going to write, there should be a single double bonds or 2 bonds to be present there. Likewise, for halogen, remember that its atomic number is 9, 17, 35, 53, and its electronic configuration is ns2, 1s2, ns2 or np5. So it indicates that in excited state there is only one electron is present in its outermost valence shell. That's why halogen can form a single bond. You remember here that whenever we are going to draw the hydrogen, you should show a single bond. Whenever we are going to draw carbon, you should draw 4 bonds. Whenever you are going to draw the nitrogen, you should show 3 bonds. For oxygen, you should show 2 bonds. And finally, for halogens, you should always draw a single bond. This is a basic concept which students always forget. So this should not happen. So you remember that just like a man is having 2 hands or animals are having 4 legs. So here these elements are having 1, 4, 3, 2, 1 legs we can say, or bonds we can say. Okay, then you see here I have shown the examples. The carbon I have shown the 4 bonds, for hydrogen I have shown 1 bond, for oxygen I have shown 2 bonds, similarly for nitrogen I have shown 3 bonds, sulfur I have shown 2 bonds, and for halogen I have shown only 1 bond. Then if you see here, if a carbon is there in the first one example where carbon is sp3 hybridized, I have shown 4 bonds and 1 hydrogen is specifically shown. If a carbon is sp2 bonded, then you remember that there is a carbon oxygen double bond is I have shown, but total number of bonds are there, 4 bonds are there. Similarly for nitrogen, similarly for sp carbon, there are 3 bonds are there, just like I have shown here. Nitrogen is triply bonded with the carbon and I have shown another bond with the carbon. So total number of bonds around the carbon is 4. Likewise here I have shown for carbonyl, I have shown for ether. But always you remember that we have to maintain the valency whenever it is possible. If the valency is not maintained, then you are going to draw a wrong structures. And you remember that there are some structures where we can find the carbon with the 3 bonds, but you remember that these are the intermediate states, or these are the radicals or ions which do not survive for a longer time. They most probably they are formed in situ and they will expire later on. So whenever you show the carbon with 3 bond, then you remember that there should be a positive charge or there should be a negative charge. Then here for nitrogen I have shown the example. Nitrogen is having 3 bonds, then carbon is having double bond, and similarly carbon nitrogen double bond is there. Then if you see here the electronegativity, this is a very important concept to remember. This helps us to show the electronegativity difference within molecule. You remember that we know the hydrogen and carbon both are having almost same electronegativity. So whenever carbon is attached with the hydrogen, then you should always remember that there is no electron separation will be there. So electron remains say on the same atom. For example, if carbon hydrogen is there, just as I have shown here, if carbon hydrogen is there, you remember that the electron remains on carbon and hydrogen remains on the electron remains on the hydrogen. But if you see the electronegativity of nitrogen, it is somewhat higher than carbon and hydrogen, and because of that reason, whenever this nitrogen is attached to the hydrogen and carbon, always remember that electrons are pulled by the nitrogen and it will carry negative charge, and the hydrogen or carbon carry positive. Just to see this example, here the carbon is attached to the nitrogen, it indicates that nitrogen is always negative charge. Hydrogen is always a positive charge whenever it is attached with the nitrogen atom. Similarly, whenever nitrogen is attached with the hydrogen, it will always carry the negative charge for nitrogen and hydrogen carry positive charge. And for oxygen, the electronegativity of oxygen is higher than carbon and hydrogen. That's why it will always carry a negative charge. Just I have shown here, the oxygen is having negative charge while carbon is having positive charge. Similarly, all halogens are basically electronegative elements. So wherever they carry the hydrogen or carbon, they will carry a negative charge, while carbon and hydrogen they will carry positive charge. Okay, so you remember that electronegativity is a very important concept. The valency is very important concept. If we deal with this, then we can draw easily the structure and we can understand organic chemistry. The remaining part we will see tomorrow, where we are going to discuss about the further topics. Thank you.